Welcome, curious minds. Ever felt the weight of a starry night's mystery, the cosmic puzzle that birthed everything we know? Get ready to step into the unknown, where the dance of galaxies reveals secrets beyond our wildest dreams. Today, we're diving deep into the mind-bending mystery that has stumped scientists and stargazers alike, the mind-boggling origin of the Big Bang's explosive energy. Imagine the universe bursting into being, but where did it get that mind-blowing power? We're about to plunge into this colossal puzzle, where the rules of reality waver on the brink of understanding. First things first, we know that energy can't be created or destroyed, right? It's one of the fundamental rules of the universe, known as the law of conservation of energy. But when it comes to the Big Bang, where did all that energy come from if it can't be created? To understand this, let's take a closer look at the law of conservation of energy. This law states that the total energy of an isolated system remains constant. It can change form or be transferred, but the total amount of energy remains unchanged. For instance, think about a moving car. When it moves, it has kinetic energy, the energy of motion. As it brakes, this kinetic energy transforms into heat through friction. The total energy within the system remains the same, only changing from one form to another. Picture the universe as a colossal, tightly packed ball of energy and matter, way smaller than a pinhead. Suddenly, around 13.8 billion years ago, this tiny point underwent an unimaginable expansion, leading to the birth of our universe, the Big Bang. Now, let's relate this mind-boggling expansion to something we encounter daily. Remember how we discussed the car's kinetic energy transforming into heat when it brakes? Well, think of the universe's expansion during the Big Bang as an incredibly accelerated version of this transformation. Just like how the car's energy changes form from motion to heat, the intense energy packed within that tiny point transformed into various forms, particles, radiation, and the fundamental forces that govern our universe as it rapidly expanded. The total energy remained constant, merely changing from one form to another. As the universe expanded and cooled, this energy transformed into matter and the building blocks of everything we know today, eventually leading to the formation of galaxies, stars, planets, and even life itself. Think of the Big Bang as this unimaginable transformation. All the energy and potential of the entire universe were packed into an incredibly small space, smaller than the tiniest thing you can imagine. Then, something incredible happened. This tiny point began expanding, stretching and growing like a balloon being inflated, but much, much faster. So, the Big Bang wasn't like an explosion out of nothing. Instead, it was this incredible event where all the energy packed into that tiny point burst forth, changing and shaping everything we see in the universe today. But here comes the mind-boggling question. If all the energy we have today existed within that singularity before the Big Bang, and we know that energy can't be created, then where did the energy for the Big Bang come from? Scientists have proposed several hypotheses to tackle this mind-boggling enigma. Let's dive into each theory and uncover the potential origins of the energy for the Big Bang. We shall first explore the theory of quantum fluctuations. Imagine a tiny, unseen world called the quantum realm, where things behave very differently than what we experience in our everyday lives. Here, particles can pop in and out of existence very quickly. It's like a constant dance where tiny particles suddenly appear, exist for an incredibly short moment, and then disappear again. This strange behavior happens because of something called the uncertainty principle. It says that in this tiny world, we can't know exactly where a particle is and how fast it's moving at the same time. Now, imagine a space filled with these tiny particles popping in and out very quickly. Sometimes, pairs of these particles suddenly appear out of seemingly nowhere. They're called virtual particles. They don't stick around for long, though, because they quickly come together and vanish, giving back the energy they borrowed from this space. In the case of the Big Bang, some scientists think that maybe, just maybe, there was a really big version of this event. Imagine an absolutely massive amount of energy suddenly appearing out of this quantum vacuum, causing an incredible explosion, what we call the Big Bang. It's like a gigantic burst of energy starting everything we know in the universe. The cyclic universe is the next theory. Imagine the universe as having a cyclical nature, where the Big Bang isn't a singular event, but part of an endless cycle of birth, expansion, and collapse, followed by another Big Bang. Some theories propose that after each expansion phase, the universe contracts back into a highly compressed state, akin to a cosmic crunch, leading to another Big Bang and the beginning of a new cycle. Think of it like the changing seasons or the ebb and flow of tides, a never-ending cycle. In this context, the universe experiences a continual cycle of expansion and contraction. If this cyclic model holds true, the energy for each new Big Bang might not need an external source, but could be a result of the collapse of the previous universe, kickstarting a new cycle. This concept challenges the idea of a single beginning of everything. Instead, it suggests that the universe might have existed in various forms through infinite cycles, with each cycle being a new chapter in the universe's story. The concept of a cyclic universe proposes that the Big Bang might be part of an ongoing cycle of cosmic expansion, contraction, and rebirth, suggesting a continuous process without a definite starting point. Lastly, we will look into multiverse and brain theory, which is the most interesting theory. Imagine not just one universe, but a vast array of them. This is the concept of the multiverse. According to some theories, our universe might be just one of many existing in a grand cosmic landscape. In brain theory, it's proposed that our universe exists on a brane, a sort of higher dimensional surface, and other universes might exist on separate branes. These branes could interact with each other in ways we can't directly perceive. Some scientists suggest that interactions between these different dimensions or branes might have released an immense amount of energy, setting off the event we know as the Big Bang. Think of it like two giant sheets. When they collide or interact in some way, tremendous energy is unleashed. Similarly, in the context of brain theory, interactions between these higher dimensional surfaces might have caused an enormous release of energy. If this theory holds, it would mean that our universe's existence and the energy driving the Big Bang might be interconnected with other dimensions or universes beyond our current understanding. The multiverse and brain theories propose that the energy for the Big Bang could have originated from interactions between different dimensions or branes, sparking the birth of our universe as a result. As we venture deeper into the mysteries of the universe's birth and the energy powering the Big Bang, we find ourselves surrounded by tantalizing theories, each offering a unique glimpse into the cosmic drama that unfolded billions of years ago. From the enigmatic dance of quantum fluctuations birthing immense energies, to the intricate interplay of multiverses colliding on higher dimensional branes, and even the cyclical symphony of the universe's endless rebirths, these theories captivate our imagination and stretch the boundaries of our understanding. The quest for the origin of the Big Bang's energy continues to push the limits of human knowledge, inviting us to ponder the unimaginable and question the very fabric of reality. If you found this journey through the cosmic unknown as thrilling as we have, hit the like button, share your thoughts in the comments below, and don't forget to subscribe for more exhilarating explorations into the depths of the universe. Let's continue unraveling the mysteries of existence together. Remember, the cosmos is an endless expanse of wonder, waiting for us to delve deeper and unlock its secrets. Until next time, keep exploring, keep questioning, and keep reaching for the stars. Thank you for joining us on this cosmic odyssey.